On this video, we're going to work some problems to review for Chapter 8. So first problem, we're going to try to solve the triangle. That means we want to find the missing sides and angles. It looks like we have an angle and the side opposite that angle, and then another side. So we're thinking, maybe this is going to be a side-side angle. So I'm going to draw it so that the angle is going to be in the lower left. That's our known angle. That makes the opposite side there be the 12. And I'm going to put the B 15 there, which makes the angle B be there, and puts angle C inside C there. So it is, in fact, side-side angle. So the first thing I want to do is say, is that opposite side bigger than the adjacent side? If so, I would know there's only one triangle possible. But sadly, it is not. So then I have to say, let's drop in that perpendicular. I'm going to call that H. And let's see what the length of H is. So H makes this into a right triangle on the left. So I can say that the sine, I lost my pen there, the sine of angle A is going to be the opposite H over the hypotenuse 15. And so H is going to be 15 times the sine of angle A, which is 28 degrees. So I'm going to grab my calculator and go 15 sine of 28. I'm in degree mode, and that's going to be 7.04. Now, the opposite side, A, is bigger than that. So H, that 7.04 is the shortest distance we could have for A that would actually make a triangle, and it meets that qualification. So since A is bigger than H and less than that 15, the opposite side, this means there are two triangles possible. Now make sure you state all this stuff. So you in particular have to find the H, notice that relationship, and say what that result is. So now what happens is we're going to have two different versions of our possible triangle ABC. One is like what we see here, where that angle B is going to be an acute angle, and A is still going to be 28 degrees. This side A is still going to be 12. That side B is still going to be 15. The other way we could put this is we can draw that so that our angle, I'm going to call it B prime, down here is actually going to be obtuse. Now this A is still 28 degrees. I'm going to call, now this is a different C, I'm going to call that C prime. I'm going to call that little side C prime. This B is still going to be 15, and this A is still going to be 12, but as you can see, we're going to get two very different triangles. So now that I recognize that, I can find angle B in this triangle by using law of sines. So I'm going to say sine of our unknown angle B over 15 is going to be the sine of 28 degrees over 12. Cross multiplying makes 12 sine B equal to 15 sine 28. So sine of B is going to be 15 sine 28 divided by that 12. So I'm going to take an inverse sine. So second sine 15 sine of 28 divided by the 12, and that's going to be about 35.9 degrees. 35.9 degrees. Now that's the angle B in the yellow triangle. Now we know that in this green triangle is really putting this side over here. So that's where that B prime is coming from. Now you can see keep bumping that with my hand there. So we can see in this triangle that if we have those two versions drawn, that we are creating an isosceles triangle. So this angle B that we just found and this angle here are congruent, which makes our B prime the supplement of that angle we just found. So that means our B prime is going to be 180 minus the 35.9. And 180 minus the 35.9, we're going to say is 144.1 degrees. So now the rest of this is going to be just routine. The hard part is done, but let's go ahead and just work it through. So back to the yellow triangle for a moment. Now that we know B, we know that angle C is going to be 180. Whoops. Let me make that a little more clear. 180 minus the 28 minus the 35.9 means that angle C, let's see, 180 minus the 28 minus the 35.9 is 116.1 degrees. So we know angle C, and then we can find side C off here. So we can say the sine of angle C over side C, and I would go with the ones that we were given. I have more confidence in those. So sine 28 degrees over 12. So cross multiplying, we have 12 sine of 116.1 is C sine of 28. So C is going to be the, let's see, 12 sine of 116.1 divided by the sine of 28. And I'm going to put this, whoops, I'm going to put that into my calculator. 12 sine of 116.1 divided by the sine of 28. And that looks like 22.95. I'm going to call it 23.0. So we have solved that first possible triangle because we have found the other two angles and the third side. Now back to the green triangle. We know now angle A and angle B prime. So let me switch back to green there. So angle C prime is going to be 180 minus the 28 minus our 144.1. So angle C prime is going to be, see, minus the 144.1 is going to be 7.9 degrees, pretty small. So that's our little angle up in the corner there. Now we want to find side C prime. So we're going to say sine of 7.9 degrees over our side C prime is going to be sine of 28 over 12. So C prime times the sine of 28 is 12 times the sine of 7.9. So C prime is going to be 12 sine of 7.9. I'm going to scroll up a little bit here. Divided by the sine of 28. And so that's 12 sine of 7.9 divided by sine of 28. And that looks like 3.5 or 3.513. There's our, we've solved that, both triangles. Okay? Ooh, I kind of ran into the other one. That's all right. We'll make it work. So now we have a different triangle with A is 41, B is 8, and C is 14. I think this is another side-side angle. So I'm going to put the angle A in the lower left-hand corner. And, oh, this is going to be a side angle side, I guess. So I'm going to say angle B is over here. So this is going to be 8. Angle C is here. So there is our 14. So this is side angle side. So we can't do this one using law of sines. So we're going to have to use law of cosines. Now, because of the information, the only way this will work is we're going to have to first solve for A, side A. So that means we want to use the version of law of cosines that says A squared is B squared plus C squared minus 2BC cosine of angle A. So a squared is going to be the 8 squared plus 14 squared minus 2 times 8 times 14 times cosine of 41 degrees. Now we can put all of this stuff on the right side of the equal sign into our calculator. So we have 8 squared plus 14 squared minus 2 times 8 times 14 times cosine of 41. Let the calculator do the heavy lifting. That's going to be 90.945. I'm not going to round, but I'm going to take the square root of that. So second x squared of that last thing, and that looks like it's 9.537. 9.537. Okay, now that we know the c, we have a choice to make, and this matters. We can find either angle C or angle B using our law of sines. Now, what we want to be careful of is let's not use law of sines to find an angle that might be obtuse, that might be bigger than 90. So between the two of those, since 14 is opposite angle C and 8 is opposite angle B, the biggest angle is opposite the longer side, so C must be bigger than B. So I don't want to find angle C using law of sines. I'm going to save that one for last. So instead, I'm going to go sine of angle B over 8 is equal to the sine of 41 degrees over A. Oops, I said that was C. I didn't read my own writing there. That's really A. So the A is the 9.537. So we have 9.537 times the sine of angle B is 8 times the sine of 41 degrees. So the sine of angle B is 8 sine of 41 degrees over 9.537. So I'm going to take the inverse sine, second sine of 8 times sine of 41 divided by 9.537, and that is 33.4 degrees. 33.4 degrees. Now we can find safely that biggest angle by subtracting our other two angles from 180. And I think we're going to find out this is, in fact, obtuse, which we couldn't have gotten correctly using law of sines. And that's 105.6 degrees. And we have solved that triangle. Okay, I'm going to scroll up here. Here's another triangle now. This one, it looks like we know side, side, side. So I'm going to label this, and I'm not really worried about if I'm doing this the right scale. A is going to, opposite that is going to be 18, and B is going to be 12, and C is going to be 9. Now, because of the information, side, 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 we're going to have to use law of cosines to start with. Now, we're going to do law of cosines to get our first angle. Then once we know that one, we'll use law of sines to get the second angle. And then we'll subtract those two angles from 180 to get our third one. We do not want to find the biggest angle using law of sines. So I would suggest let's just find the biggest one first using law of cosines. We can see the biggest one is going to be angle A because that's opposite the longest side. So we're going to say A squared is B squared plus C squared minus 2BC cosine of that angle A we're trying to find. So we're going to get 18 squared is equal to 12 squared plus 9 squared minus 2 times 12 times 9 times cosine of angle A, and we're going to try to solve that for angle A. So I'm going to take the 18 squared minus the 12 squared minus the 9 squared first, and I'm going to hold off on this stuff until we can see what that's equal to. So 18 squared minus 12 squared minus 9 squared is 99. And the 2 times 12 times 9 is, that's going to be a negative 216 cosine of angle A. Then we're going to divide by the negative 216, and we can see, because that cosine is equal to a negative, that that does put us in quadrant 2, and so that means we are going to, in fact, get an obtuse angle. So we're going to take the inverse cosine, so second cosine of a negative 99 divided by 216, and that's going to be 117.3, so 117.3 degrees. So our angle A is 117.3 degrees. Now we've got the obtuse angle out of the way. Neither of the other two, we can't have two obtuse angles. So now the pressure's off. We can find whatever one we want. I'll just find angle B just for no particular reason. So I'm going to use law of sines and say sine of angle B over 12 is going to be the sine of our angle A, which is 117.3, over side A, which is the 18. So cross multiplying, 18 times the sine of angle B is going to be 12 times the sine of 117.3. So sine of angle B is 12 sine of 117.3 divided by 18. We'll do our inverse sine. And so in second sine of 12 sine of 117.3 divided by 18 is 36.3. So 36.3 degrees. And then once we know A and B, we can get angle C by subtracting from 180. So we will subtract these other two, and so our angle C will be 180 minus the 117.3 minus the 36.3, and that looks like 26.4 degrees. So we just don't want to find the biggest angle using law of sines. Okay, let's see if we can find rectangular coordinates for the following. So we need to know that x is going to equal our cosine theta and y is going to equal our sine of theta. And if you don't remember it, you can recreate it. It comes from this relationship. And you can see that the cosine of theta is x over r and the sine of theta is y over r. So for us, we're going to get x is equal to negative 4 cosine of 2 pi over 3. And we know these, so that's negative 4. Let's see, the reference angle for a cosine of 2 pi over 3 is going to be pi over 3. We know that cosine starts big, so it's going to be 1. So pi over 3 is going to go 0, pi over 6, pi over 4, pi over 3. 0, pi over 6, pi over 4, pi over 3 is going to be here. Cosine starts big, so it goes 1, square root of 3 over 2, square root of 2 over 2, 1/2. In quadrant 2, cosine is negative, so that's going to be a negative 1/2. And so that will make our x-coordinate a positive 2. Y is going to be negative 4 times the sine of 2 pi over 3. So that's negative 4 times, in a similar fashion, our reference angle is pi over 3. Sine starts small, so it's going to go 0, 1/2, square root of 2 over 2, square root of 3 over 2. In quadrant 2, Sine is still positive, and so we're going to get a negative 2 square root of 3. So our rectangular coordinates are going to be 2 comma negative 2 square root of 3. Okay, so let's do our next one. So let's do, what color? I guess we can go ahead and do white. So x is again going to be 6 times the cosine of negative 5 pi over 6. So that's going to be 6 times. Now a negative 5 pi over 6 is going to put us over here in quadrant 3. Our reference angle is going to be pi over 6. So we're going to go angle 0, angle pi over 6 is that first one. Cosine starts big, so that's going to be 1 square root of 3 over 2. In quadrant 3, everything is negative, so we're going to get 6 times negative square root of 3 over 2, so that will be a negative 3 square root of 3. Y is going to be 6 times the sine of negative 5 pi over 6. So that's going to be 6 times, again, reference angle is pi over 6. Sine starts small, so it's going to go 0, 1/2. In quadrant 3, sine is also negative, so that's going to make that be a negative 3. And our coordinates are going to be negative 3 square root of 3, comma, negative 3. Okay? Now we're going to try to find 4 different polar representations for the rectangular coordinates, negative 3 square root of 3, comma 3, using angles, theta, that are between negative 2 pi and positive 2 pi. So r, so we need the r and the theta is what we're looking for, r and theta. So r, we know, is going to be the square root of x squared plus y squared. So we're going to get negative 3 square root of 3 squared plus the 3 squared. So 3 times 3 is 9, square root of 3 times square root of 3 is 3, 9 times 3 is 27, and 3 squared is 9, 27 plus 9 is 36, and the square root of 36 is 6. So our r is 6. Now theta, we can do, theta is the inverse tangent of the y over the x. And that might be a little hard to figure. We can do it this way. We could say that's going to be the inverse tangent of, and if we cancel the 3's, that'll be negative 1 over square root of 3. Now, if you're good at this and you can think of these values are going to be, so I'll do this 2 ways. If you're really good at this, we can think of this as coming from sine theta over cosine theta. And if these are known values, I'm going to ignore for a minute the negative sign. We can think of that as 1/2 over square root of 3 over 2. So the same angle that makes sine theta 1/2 makes cosine theta square root of 3 over 2 makes tangent of theta 1 over square root of 3. And that's going to be a reference angle of pi over 6. Now alternatively, we could graph this and say we're in quadrant 2 because our x value is negative and our y value is positive. So we could put our negative 3 square root of 3, our opposite is going to be 3, and we just found out the r is 6. So now we can turn it into a sine or a cosine rather than a tangent, which tends to be pretty difficult. So we could say the sine of this angle theta is opposite over hypotenuse, and there's our 1/2, which is again going to give us a reference angle of pi over 6. But we are in quadrant 2, so if the reference angle is pi over 6, that's going to make our angle theta actually be 5 pi over 6. So one set of coordinates is going to be r is 6 and theta is 5 pi over 6. And I'm going to draw a picture there. That's getting us to this point over here that's in quadrant 2. Now, we could also get to that same place by going around our angle this way. That would be a negative, and can you see that's going to be a negative 1 pi plus another 1/6 is 1 1/6, or 7 pi, negative 7 pi over 6. Now those are the two values that use positive values of r. If we want to get an angle that will get us to quadrant 2 with a negative value of r, then we need to extend that 5 pi over 6 down into quadrant 4. We can see our reference angle is pi over 6, so this angle could be a negative pi over 6 to go with our negative value of r, or we could come all the way around this way, which would be 12/6 minus 1/6 would make that be 11 pi over 6. So these are our four polar representations using angles theta between negative 2 pi and 2 pi. Okay. And these are tricky, these next ones. So we are going to try to change these from rectangulars that have x's and y's into polars that have r's and thetas. So we know that y is equal to r sine theta and x is equal to r cosine theta. So we'll say r sine theta is equal to the square root of 3 times r cosine theta. Now we'd like to get the r by itself, but sadly, if we divide by r, it's going to drop out altogether. That's okay. So since we lost our r, our goal now is to get theta by itself. So that was a square root of 3. So I'm going to divide the cosine theta to the other side, and then recognize that as tangent theta is equal to square root of 3. So we're going to take the inverse tangent of both sides. And so that will give us theta equal to, and now we got to figure out what is the inverse tangent of square root of 3. So again, we're thinking tangent theta equals square root of 3. If you're good at this, we can think of that as coming from square root of 3 over 2 over 1/2. And so the same angle that makes sine theta square root of 3 over 2 makes cosine theta 1/2 and makes tangent theta square root of 3. That is going to be pi over 3. Alternatively, we could draw our triangle and say the angle whose tangent is square root of 3 means opposite over adjacent is square root of 3 over 1. Using Pythagorean theorem, square root of 3 squared is 3, plus 1 squared is 1, makes 4, square root of 4 is 2, and now we can again make it into the angle whose sine is square root of 3 over 2, or the angle whose cosine is 1/2. At any rate, that's going to get us to theta equals pi over 3. That is actually our polar equation for that. That's how we get a line through the origin, is just that angle. Okay, now the next one. We're going to start by trading in again x for r cosine theta squared minus 4 times, guess I don't need parentheses, r cosine theta plus r sine theta for y squared plus 6r sine theta is equal to 0. I'm going to bring these together. That's r squared cosine squared theta plus r squared sine squared theta. I'm going to move the others to the other side. There's a 4r cosine theta and a minus 6r sine theta. I bumped it again with my hand. If we factor the r, I'm going to bring my pen back up. If we factor the r squared out, we have our most famous of all trig identities, sine squared plus cosine squared. And I'm going to leave these as they are for a moment. And so cosine squared plus sine squared is just 1, so that gets us to r squared is 4r cosine theta minus 6r sine theta. So we want to get just r by itself, so if we divide 1r out of there, we get 4 cosine theta minus 6 sine theta, and that is actually our polar equation. R equals some function of theta. Okay, I'm going to slide this over a little bit to give myself a little more room. So we're going to start again by calling x r cosine theta and the y r sine theta. Oops. And that's equal to 1. So that looks like 4r squared cosine theta sine theta equal to 1. We'd like to get r by itself, but I don't think we really want to do a square root. So we're going to go divide by the 4 and the cosine theta and the sine theta. Now, we're not going to square root both sides. We'll live with the r squared, because the radicals just make it look messier. But we want to split this 1 over 4 cosine theta sine theta and separate that and think of that as 1/4 times 1 over cosine theta times 1 over sine theta, because then we can say that the cosine theta is really a secant and the sine theta is a cosecant theta, and that's going to be our equation in polar form. Okay, I'm going to slide it back over and up, and we're going to go the other direction. So now we're going to convert these polar equations into rectangular equations. So the r, we know, is hopefully the square root of x squared plus y squared. So we can square both sides, and that will give us x squared plus y squared equals 4. And that's a good place to stop. We don't really want to get y by itself here, because we would have to get a plus or minus square root, and this is actually a little more informative. Maybe you recognize that as a circle centered at the origin with radius 2. The next one, we're going to think of that as 5 times, and the cosecant is 1 over sine theta. So if we multiply that sine theta to the other side, we're going to get r sine theta equals 5. This is good news because r sine theta is y. And there it is. That's actually just the horizontal line, y equals 5. Next one's kind of tricky. So we're going to trade the theta in for the inverse tangent of y over x equal to 2 pi over 3. Now, to get rid of that inverse tangent, we're going to take the tangent of both sides. So that will cancel the tangent and the inverse tangent, getting us to y over x. Now, we need to know that the tangent of 2 pi over 3 is the sine of 2 pi over 3 over the cosine of 2 pi over 3. Let's see, the reference angle for an angle 2 pi over 3 is going to be pi over 3. In quadrant 1, the sine of pi over 3 is going to be square root of 3 over 2, and the cosine of pi over 3 is 1/2. That will get us to square root of 3, but in quadrant 2, the cosine is negative, so that's going to give us a negative square root of 3. So we're getting y over x equals negative square root of 3. So multiplying the x to the other side, we see it's a straight line with slope negative square root of 3 and y-intercept 0. Okay. We're going to do some of these polar graphs. So we want to be able to name it, and then we're going to try to graph it. For limasones, we're going to find the intercepts, and for rose curves, we're going to find the angles where those petals lie. So anything in the form a plus or minus b sine theta or cosine theta is going to be a limason. So since this number is bigger than that number, this is going to be, and you don't have to know the name first. Sometimes it's easier to graph it first, but it'll turn out to be, we're going to see a dimpled, or sometimes called a dented limason. Dented limason. So what we're going to do is, for limasones, we're going to plug in 0 and pi over 2 and pi and 3 pi over 2 and see what that gives us for r. Then we'll plot those points and we'll try to figure out what happens from there. So at 0, sine of 0 is 0. I bumped it again, so I have to come back with my pen. So since the sine of 0 is 0, r is going to be 3. At pi over 2, sine of pi over 2 is 1. So 3 plus 2 times 1 is 3 plus 2 is 5. At pi, sine theta is 0 again, so we're back to 3. At 3 pi over 2, sine is negative 1, and so the r is going to be 1. So I'm going to slide this up for the graph. So our graph, we are going to say that at angle 0, we're going to be at 3. And so I'm going to label that with x and y coordinates, 3, 0. At pi over 2, we're going to be at 5. 1, 2, 3, 4, 5. I have to extend that a little bit. And so that point is going to be 0, 5. And at pi, we're going to be 3 away from the pole. In rectangulars, that's negative 3, 0. And at 3 pi over 2, we're going to be 1 away from the pole. Whoops. And we're going to call that 0, negative 1. So it's not very interesting, but we're just going to be, I'm sorry, this is not a dimpled or dented one. This is actually, yeah, it is 2. So it's going to be like this. Then it's going to start over here and then dip down for our dimple or dent, and then work our way over there. So it's pushed in a little bit right there when it goes in towards the pole. Okay, I'm going to come back up. Now this is a rose curve, and because the n is odd, that means it's going to have 5 petals. Now the first petal, so the first petal is going to be on the angle where sine is first equal to 1. And sine is equal to 1 when it's an angle of pi over 2. And that means if we divide by 5, that's going to be at an angle of pi over 10. So I'm going to draw our xy axis. Because our r here, this is 2, the biggest a sine can be is 1, so the biggest r can be is 2 times 1. So these petals, this curve, is going to lie on a circle of radius 2. So I'm going to say these are going to be 2. Now our first petal is going to be at pi over 10. So I'm going to come out here and label that theta equals pi over 10, and that's going to be the end of our first petal. Now the spacing between petals is going to be 2 pi, that's a full circle, divided by the number of petals, which is 2 pi over 5. So that means the second petal is going to lie on the angle pi over 10 plus 2 pi over 5, 2 pi over 5 is 4/10. That's going to make that be 5/10 or pi over 2. So there's the end of our second pedal. Our third pedal is going to be that pi over 2 plus another 2 pi over 5. So that's 5/10 plus 4/10 is 9 pi over 10. That's going to be over here. There's our theta equals 9 pi over 10. I guess I should say that's going to be at theta equals pi over 2. And our fourth pedal is going to be 9 pi over 10 plus another 2 pi over 5. So that's another 4/10 plus 9/10 is 13 pi over 10. So let's see, that's 10/10. So 13 pi over 10 is going to be somewhere over there. And that's going to be the end of our next pedal. And our fifth and final pedal is going to be that 13 pi over 10 plus another 2 pi over 5, which is 4/10. That's going to be 17 pi over 10. So that's going to be right down over here. It's going to kind of look like a star there. That's going to be our theta equals 17 pi over 10. So the way we try to draw these is we start with our pen at the end of the first pedal. We look diagonally across 180 degrees and then slide over counterclockwise to the next pedal. So I'm going to connect this pedal with that end pedal going through the pole, something like that. So it kind of makes for narrower pedals. Then I'm going to do the same thing, through the pole to the next one, through the pole to the next one, through the pole to the next one, and through the pole back where we started, and it didn't look very good. Those are all supposed to be going through there. You're going to have to use your imagination on that one. Okay, now we have another limacon because it's in the form a plus b cosine theta. So these I think are maybe a little easier, I don't know. So we're going to pick theta equals 0 again, pi over 2, pi, and 3 pi over 2. And we're going to find the values of r for each of these. So when we put in 0, cosine of 0 is 1. 2 times 1 is 2, plus the negative 2 is going to make that be 0. Pi over 2, cosine pi over 2 is 0, so the r is going to be negative 2. These are going to be tricky to graph. At pi, cosine of pi is negative 1, times 2 is 2, plus another negative 2 makes a negative 4. And at 3 pi over 2, cosine's back to 0, and so we're going to get negative 2. All of these negative values of r are going to be kind of challenging. So let's see what we can do here. So at angle 0, we're going to go 0. That's going to be right there. So that is going to be the point 0, 0, which is the same in both polar and rectangular. Now at the angle pi over 2, we're going to go to a negative 2. So that's going to be down through the pole to this point right here, which we're going to call 0, negative 2. Okay, now we're going to then go to pi, which is on this angle. A negative 4 is going to shoot us back through the pole 4 and put us actually at 4, 0. Kind of crazy. Now, then we're going to be at 3 pi over 2, which is down here, but a negative 2 is going to put us back up here, which we'll call 0, 2. Now, graphing these is really challenging. We're starting at 0, 0. As we imagine sweeping through an angle this way, so going from 0, working our way to pi over 2, our r values are going to be negative, so we're going back through the pole this way to get to 0, negative 2. As we go from pi over 2 to pi, we're sweeping this way, but our r values are negative, so that's going to shoot us back through the pole. And as we go to an r value of -4, which is actually going to be over here, we're going to end up going this way. As we work our way from pi to 3 pi over 2, we're sweeping through here, but again we have negative r values, which are shooting us through the pole into quadrant 1, and we're going to connect to this point. And finally, going back to, say, 2 pi, as we go this way, we're going, so our angle is going from 3 pi over 2 to 2 pi, but the r values are negative, which are going to shoot us back through the pole into quadrant 2, and this is, in fact, a cardioid. That's about as tough a graph as you can get with limasomes. All right, very good.